Good day everyone. Today we're diving into the world of microservice architecture and the patterns that make it work. We will explore what these patterns are and how they help build modern software systems. As we start exploring, we're looking at how designs and setups come together to shape microservice architecture. To understand this better, we've gone through some important steps. First, we'll define some key design patterns like service registry and circuit breakers that are used in microservice architecture. Then we'll dive into how these patterns are actually used in real-world systems. But we'll not stop there. We'll also check how these tricks affect important things like how big our system can grow, what can handle mistakes, and how it's easy to keep everything running smoothly. So lastly, we'll explore the tricky part and the best way to use this pattern. Think of it like learning the best moves in a video game to beat the toughest level. Firstly, we'll start with some basics. So what are design patterns? So design patterns are like blueprints or templates we can say for solving common problems in software development. They are reusable solutions to recurring design problems that software engineers encounter. These patterns provide a way like how to structure code and how to design a system in a way that promotes code reusability, flexibility, and maintainability. What about microservice architecture? This architectural style I explored several times in my previous videos totally devoted to microservice architecture. You can link there. So let's start with our first step of our research. So, so as we are diving into the world of microservice architecture where software is like a puzzle made of tiny pieces, but how do we keep all these pieces working together smoothly? That's where design patterns come in. So in this step, we'll explore some of these handy patterns like service registry and circuit breaker that make microservice architecture work like magic. That will make microservice architecture more efficient. And we'll start with a service register. So imagine you have a big digital address book where everyone in your neighborhood writes down their name and phone number. That way, whenever you need to call someone, you can just look them up in the book and give them a ring. That's basically what the service register does for microservices. So it's like a hub where each microservice registers its location and contact details. So when one microservice needs to talk to another one, it can quickly check the service registry to find out how to reach it. This makes connection between microservices easy and efficient, even if they're constantly moving around or changing. Next, we'll talk about circuit breaker pattern, one of the most popular and widely used design pattern in microservice architecture. So imagine you are playing a game with your friends and suddenly someone spills a drink on the table, so causing a chaos. To prevent the mess from spreading and ruining the entire game, you quickly put a barrier to contain it. That's pretty much what circuit breaker does in the world of software. So in microservice architecture, where many small pieces of software work together, a circuit breaker acts as a safety mechanism. It monitors the health of each service, and if one starts acting and causing errors, the circuit breaker steps to stop those errors from spreading to other parts of the system. So instead of letting one problematic service break down the whole system, the circuit breaker temporarily interrupts communication to that service. So this prevents the errors from snowballing and allows the rest of the system, the rest of the code to continue running smoothly. So it's like as I said, it's like putting a temporary barrier to contain the chaos, to preserve the chaos until the problem is fixed. So now about the third design pattern. So imagine like a big shopping mall with lots of stores. Instead of going to each store separately, you enter through the main entrance, and there's someone there to guide you to the right place based on what you need. So that's kind of the gateway pattern microservice architecture. So in simple terms, the gateway pattern is like a central hub where all our requests from users come in. Instead of user needing to know where each little service is located, they just talk to the gateway, to the hub, and it figures out where to send the request. So it's like having to show you around the mall, making things easier and more organized. So plus we can say that gateway pattern can also do other useful stuff like checking if you're allowed to access certain areas or making sure everything is running smoothly. So we have talked about cool design patterns that make it all work smoothly, like the digital address book, like the service registry or circuit breaker. Now we'll now go to the next part. We'll explore how companies put them into action, put these design patterns in action, what challenges they face, and what tricks they've learned along the way. So first we'll start with the service registry. So service registry, as I said, is like a digital directory where microservices registers themselves. It makes it easy for other services to find and talk to them. So it's implemented by setting up the central register where services put their info, like their names and where they can be reached. This helps keep communication between services smooth and flexible. Using the service registry pattern makes it simple for services to find each other even if they're constantly moving around. So if one service has a problem, the registry helps redirect requests to another healthy service, keeping the system running smoothly. However, setting up and maintaining the registry itself requires careful planning to make sure it's reliable and doesn't slow things down. Next, we'll talk about the implementation and the usage of circuit breaker pattern. So circuit breaker pattern acts as a guardian for, as I said, for microservices, preventing the system wide failures when one service encounters any problem. It's like a safety net that automatically kicks when something goes wrong. So this pattern is implemented by adding the layer of logic around the service calls. So when the service starts falling or becoming unresponsive, the circuit breaker trips and temporarily stops further requests from going through. Circuit breaker pattern helps prevent problems from spreading throughout the system. It allows the rest of the services to keep running smoothly while the troubled service gets fixed. Once the issue is resolved, the circuit breaker resets and normal operations resume. Next is a gateway pattern. So gateway pattern acts as a helpful guide for clients trying to access different parts of microservice system. So as I said, it's like a central hub that manages all incoming requests and directs them to the right place. This pattern is implemented by setting up a single entry point for the clients, typically a server or API gateway. So using the gateway pattern makes it easier for clients to interact with microservice system. Instead of needing to know where each service is located, they can just talk to the gateway, which handles all the routing, like behind the scenes routing, and additionally it performs other tasks like authentication, authorization, request transformation, simplifying the client experience, and offloading common concerns from individual services. And so this is all about the implementation and usage of these design patterns like service registry, circuit breaker, and gateway pattern. So now we're going to explore how design patterns affect our software system in three key areas like scalability, resilience, and maintainability. We'll take a closer look at how these patterns influence the system ability to handle growth, recover from failures, and remain easy to manage over time. So we'll start with the service register pattern. So firstly, about scalability. The service register helps our system grow smoothly by making it easy to add new services. Instead of each service needing to know about all others, they can just register themselves with the registry. This makes it simple to add or remove services without causing disruptions. What about resilience of what about service register impact on resilience? So when things go wrong, like a service stops working, the service register helps our system bounce back quickly. It keeps track of where all the services are. So if one goes down, the other can still find each other and keep things running smoothly. So this is make our system more resilient to failures. What about maintainability? As our system evolves, the service register makes it easier to keep everything organized instead of needing to update every service individually. When something changes, we can just update the register. This saves time and effort, making our system easier to manage in the long run. So now let us talk about the circuit breaker pattern, how it affects our system. Firstly, we'll also start with the scalability. So the circuit breaker pattern helps our system handle more users and requests without crashing. So when service starts acting like responding slowly or returning errors, the circuit breaker steps in to temporarily stop sending requests to that problematic service. This prevents the problem from spreading and gives the service time to recover. What about resilience? So when there is a problem with the service, the circuit breaker helps our system stay strong and keep going. Instead of letting error from one service break down the whole system, the circuit breaker isolates the issue and keep it from affecting everything else. What about maintainability? The circuit breaker pattern makes it easier to keep our system healthy and easy to manage. By automatically handling problems with services, it reduces the need for manual intervention and troubleshooting. So this saves time and effort, making our system simpler to maintain in the long run. And lastly, we'll talk about our last design pattern in this presentation and its impact on scalability, resilience, and maintainability. So firstly, with the scalability. So the gateway pattern makes our system more scalable by centralizing access to multiple services. Instead of clients directly contacting individual services, they interact with the gateway. This simplifies the client's experience and reduces the complexity of managing service-to-service communication. Next is the resilience. So the gateway pattern enhances the resilience of our system by serving a single entry point for the client. So if service becomes unavailable or experiences any problems, any issues, the gateway pattern can implement a fallback mechanism or to alternative fallback mechanism. This isolates failures and prevents them from affecting the entire system. What about maintainability? So implementing the gateway pattern improves the maintainability of our system. By centralizing cross-cutting concerns and promoting consistency, by handling common tasks like authentication, request routing, and protocol translation, the gateway reduces duplication of code and simplifies services implementation. So this makes it easier to update and evolve the system over time, as the changes can be applied to the gateway without affecting the individual services. So this is all about impact of these three specific design patterns on scalability, on quality attributes like scalability, resilience, and maintainability. So we'll go to the next part of our next step of our presentation of our research contest, and we'll explore the challenges and best practices for applying design patterns effectively in microservice architecture. So let's dive and uncover how to build robust and resilient and manageable systems. So first we'll start with some common challenges that we'll face when implementing and using design pattern. Firstly, we'll counter the complexity problem, the complexity challenge. So microservice architecture can get pretty complex with lots of moving parts, so applying design patterns can sometimes make things even more complicated. So we can mention an example. It's like trying to organize a big party where everyone has different preferences, so it can get messy. So another challenge that we might face is integration. So making all the microservices work together smoothly can be tricky. Sometimes when we apply design patterns to one part of the system, it can affect how other parts interact. So it's like trying to fit puzzle pieces together, and sometimes they just do not quite match up. Next is the overhead. So overhead is something like when design patterns come with an extra overhead, like additional code or configuration. So this can slow down the development and makes the system harder to maintain. So it's like adding more ingredients. Next, we'll talk about the flexibility. So sometimes design patterns can make the system less flexible. They may introduce constraints or dependencies that limit future changes or adaptations. So it's like building a house with a specific blueprint. So it's great at first, but can be hard to make changes later on if needed. And lastly, about the performance impact, depending on how design patterns are implemented, they can, like design patterns can impact system performance. Sometimes some patterns may introduce overhead or inefficiencies that slow down the system. So it's like adding extra weight to the vehicle, so it might affect its speed and fuel efficiency. So generally, it might impact the performance. It may, how to say, lower the performance of a program if we use a lot of design patterns. So this is all about challenges that we'll face implementing and using design pattern. So now let us talk about the second part of our step. As our first step is like best practices. So best practices for applying design pattern. So first we need to understand the problem. Before jumping into using a design pattern, make sure we need to make sure that we can fully understand the problem. Different patterns are suited for different challenges, so choose the ones that best fits your specific situation. Or another best practice is keep it simple. So what I mean by keeping simple is like do not complicate things, like do not make a complex system. Using design patterns to simplify, use the design pattern to simplify your code and make it easy to understand. So aim to clarity, readability, even if it means simple using like simple patterns or breaking complex problems into smaller, more manageable pieces. Another best practice that we can apply for using design patterns is modularizing the code. So what I mean by modularizing the code is like breaking our system into smaller reusable components. So this makes it easier to apply design patterns to individual parts of our system and promotes code reusability and maintainability. A last best practice that I recommend for you for applying design patterns is like testing our pattern. So always test your design pattern thoroughly to ensure they're working as expected. Write unit tests and integration tests to verify that your patterns are solving the intended problem and not introducing new bugs or issues. So this are the best practices for applying design patterns. And we come to the last step of our presentation of our research contest, talking about modifications to design patterns to make our system work even smoother. So when it comes to supporting microservice architecture, so the service registry is like design pattern that we chose, plays a crucial role in enabling service discovery and communication. So however, to ensure optimal performance and scalability in increasingly complex system, several modifications can be considered. So firstly, there are some modifications to service registry, and there are dynamic configuration, health monitoring, load balancing. These are two modifications for making service registry more efficient. So what I mean by dynamic configuration is like implementing the dynamic configuration capability with the service registry that allows for real-time updates to service information without the need for manual intervention. What about health monitoring? It's like integrating health monitoring functionalities into the service registry, and it will enable continuous monitoring of service instances' health status. So by periodically checking the availability and responsiveness of services, the registry can automatically update the service information and remove unhealthy instances, ensuring that clients only communicate with healthy services. What about circuit breaker patterns? So to optimize circuit breaker pattern effectiveness in supporting microservices, Several modifications can be considered. First is a dynamic threshold, then failure prediction, and kernel fallback strategies. So dynamic thresholds is it's like mechanisms that allows the circuit breaker to adapt its behavior based on real-time performance metrics of server instances. By dynamically adjusting the thresholds such as error rates or response times, the circuit breaker can accurately detect deteriorating service conditions and proactively mitigate potential failures. What about failure prediction? It's like enhancing the circuit breaker with the failure prediction capabilities enables it to anticipate the service failures before they occur. By analyzing historical services and performance data and identifying pattern indicative of impending failure, the circuit breaker can preemptively trip and prevent requests from reaching the deteriorating services, therefore minimizing impact on system availability. To optimize gateway pattern effectiveness in supporting microservice architecture, several modifications can be considered. First, there are dynamic routing, protocol translation, and caching. So dynamic routing is like implementing routing like within the gateway patterns that will enable flexible routing of the client request to the appropriate microservice instances based on runtime conditions or client-specific attributes. What about protocol translation? Enhancing the gateway pattern with the protocol translation capabilities allows seamless communication between clients and microservices that use different communication protocols or data formats. What about caching? It's like introducing caching mechanism. As we know, it's like caching helps a lot in memory. So introducing caching mechanism in the gateway pattern allows for efficient caching of frequently accessed data or responses from microservices. By caching responses at the gateway level, the redundant requests to microservice can be avoided, like reducing latency and improving system performance. Additionally, we can say that caching can help mitigate the impact of service failures by serving stale data during the service outages. So this is all about like modification to the design pattern, to the specific design pattern. There are lots of like recommendation like using dynamic configuration, health monitoring, caching, protocol translation, dynamic routing, failure prediction, and like to optimize the desired design patterns like service registry, circuit breaker pattern. We can use this modification. Here, in conclusion, I won't say that that's all for our video presentation talking about the design patterns used in microservice architecture. In this presentation, we have talked about three specific design patterns that widely used in microservice architecture, like service registry, circuit breaker, and gateway pattern. In this presentation, we have talked about its implementation, its usage, the challenges that we might face, how to optimize these patterns, and also we talk about best practices for applying these design patterns. And that's it. Thank you for your attention. Hopefully you'll get some information, and that's all for today.